Right, so now we're looking at domains of functions from formulas. I'm not sure MyMathLab's going to ask anything about ranges here. I am not, so don't worry about those. If MyMathLab asks you, accept the little red X and move on. Or if you're obsessed with those green check marks, feel free to check out whatever materials they provide for you to learn about the ranges. Let's talk just a little bit about function notation first. You're all familiar with equation notation, y equals 3x plus 5. You know that you can plug a number in for x like 2. 3 times 2 is 6 plus 5 would be 11. So we would have the point 2 comma 11 on the graph of that function. But think about what it takes to ask that question. What is the output, or what is the value for y that we'd get if we put a 2 in for x? That's an awful lot of words to ask for what would y be when we put in a particular value for x. So somebody invented function notation a while back, which really just makes it easier for us to ask that question. Instead of asking, what is the value for y when x is 2? Here I would just say, what is f of 2? And that would be 11. Much easier to write than what is the value of x, blah, 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 and also much easier to say. So if you're unfamiliar with function notation, that is just really the way we're writing y that makes it easier to ask that question, what do we get for y when we put a particular value in for x? Now, the domain, remember, is all the numbers that we can put into a function, that we're allowed to put into the function. So think of it that way. What numbers are you allowed to put in here? Well, is there any number that you cannot multiply by 3? No, there is not. Is there any number you can't add 5 to? There's not. So we can put anything at all we want into this function. And if you think about the graph of this function, it's a line. It's got the arrows on both ends, which means it goes from negative infinity to positive infinity. And that is our domain, which for the rest of this, I'm just going to say all real numbers. Remember, MyMathLab prefers this. I prefer all real numbers because that's the way mathematicians write it. It's short and easy. All right, is there any number we can't put into this function? No, we can square any number at all. We can multiply any number by 5. We can subtract 12 from any number, and we can add and subtract any numbers we want. So our domain here is also going to be all real numbers. If you think about operations that can cause a problem, like in a calculator, something that might give you an error, that operation's not allowed. The only one we really have that we're ready to discuss yet, we're going to talk about square roots a little bit in the future, but for the moment, the only operation we have that can cause a problem is division. And the only time we run into a problem with division is when we try to divide by 0. So the domain of this function here would be any number. We can divide 12 by any number except for 0. So our domain is going to be, here's how I write it and how I want you to write it, all real numbers except for 0. Backslash for except. And that's the way professional mathematicians would write it. Not that I'm one of those. The way MyMathLab's going to want it is all of the numbers from negative infinity to 0, not including 0, union all of the numbers from 0 to infinity. Fun and efficient, right? Just think about your number line, right? You get your number line that goes from negative infinity to positive infinity, and you're going to pull 0 right out of the middle of that number line. That leaves you with two pieces, negative infinity up to 0 not including, and 0 to infinity not including the 0. Right, so when you're talking about domains, the only thing you're going to need to worry about for the moment is what value for x would make the denominator equal to 0. Right here, if we put a 6 in, we get 6 minus 6 is 0, and that would cause a problem. So our domain here is going to be all real numbers except for 6. And you can write it that way. I'm not going to bother anymore. What number for x would cause this denominator to be 0? Well, just set it equal to 0. 2x plus 3 equals 0. If you can't just do it in your head, subtract 3 from both sides. You get 2x is negative 3. So x is negative 3 over 2. So our domain is going to be everything except for negative 3 over 2. Right? It's always all real numbers except for whatever makes the bottom 0. Notice, don't care about the top at all. The top doesn't affect the domain. And again, this is for purposes of this section. Don't hold it against me later when we run into different situations. All you need to worry about in this section is numbers that make denominators equal to 0. Now, if I was evil when I put together the MyMathLab assignment, you might run into one like this where you actually have to solve a quadratic for that denominator. X squared plus 2x minus 15 equals 0, and that factors to x plus 5, x minus 3. So x can't be negative 5 and x can't be positive 3, so you'll end up with negative infinity to negative 5, not including, negative 5 to 3, not including, and then 3 to infinity, not including. Like I said, if I was feeling evil at the time, I might have assigned that one in MyMathLab, but I sure hope I wasn't. There will not be anything like this on any test I've ever written. We'll stick with nice ones like that.